JK with an LS3 6.2 6L80. Good combination. We've done it many times before. This JK has our latest technology. It has our easy bolt-in engine mounts. Bolt-in engine mounts are advantageous for several reasons. One, you save many hours of having to cut and grind your chassis. We use a full-size hydraulic GM mount. We've tested it up to 500 horsepower. We've had no failures. Some countries, European countries, Arab countries, require no modifications to the frame or chassis. So these easy mounts meet that standard. If you have to go through engineering, there is no modifications to the chassis. In fact, you could say that this swap is reversible. You could install a V6 back in your JK with not much effort. Our swap is not as invasive as other swaps. With some swaps, you need to modify the suspension, modify the firewall or steering, drill holes. There is no cutting, grinding, or drilling in our entire swap. We've been doing the LS-JK swap now for about 10 years, and we've run into pretty much every configuration, whether you have single S-Pod, dual S-Pod, Mopar big brake kit, underhood ARB compressor. We've adapted and we've made hardware to fit every application, or virtually every application. So by adding the easy engine mounts to our build, we've knocked not only a lot of hours off, but we've made the swap less invasive. Whether you're doing a Hemi or an LS or a supercharger, the less fabrication you do to the original chassis, the better. When it comes time to do engineering or safety inspections, the less modifications that you've done, the less paperwork and testing you'll have to subject yourself to. This engine is running our JK accessory drive, so we're using original JK components: power steering pump, alternator, and air compressor. We're running the early JK accessory drive even in the Pentastar JKs, and the reason is the Pentastar accessories are a little bit goofy, the alternator's backwards. We may support the Pentastar accessories in the near future, but the reality is the early JK accessories are readily available and they're not very expensive, so you might want to just upgrade to that. Of course, we can still support the GM drive if you prefer, but I think we should talk about that for a second. There's some advantages to each. Running the GM drive keeps your engine all GM, but it can be difficult sometimes to lay the GM accessory drive out properly. Most LS and LT GM engines run their air compressors on the passenger lower side of the engine. Unfortunately, the JK runs its upper control arm bracket on the passenger side, right where that air compressor is. Now, in the LTs, it's not as bad because the LT doesn't use a sub-bracket. The LS engines, they run a bracket between the air compressor and the block, and it moves it out and it is down further, so there's more conflict. With the LT, it's up higher, tucked in, so we have no issues with the LT essentially. However, that upper control arm on the stock JK gets very close to the compressor. In fact, it'll smack that compressor unless you have a lift. You want at least a 3.5 inch lift. Then you got to run bump stops. So that's a little bit of an inconvenience. Secondly, depending on the compressor you run, you may have frame interference. The air compressor on the passenger lower, depending on where the outlets are, can be very tight to the frame. So we see guys sectioning frames. Again, we don't want to do that. We don't want to modify the vehicle. If you have enough lift, you can take a sanding compressor, rotate it around, and run the lines out the bottom, but you got to have 4 to 6 inches of lift at minimum. If the lines have to come out the top, you can run them. You can run short drop fittings, which are essentially aluminum or steel blocks with lines coming out the ends. There is no tube that's bent, so that saves you some space. You do have to run the AC line from that block all the way up to the firewall, so it's not really that big of a deal, but there is some extra line there, as well as using full custom hoses, which we don't have to do with our JK drive. You can also run a smaller air compressor like a 7 Series stand-in using a dirty dingo mount, and there's others out there, and that works okay. One issue with that is if you do have a large four-door JK, you have a lot of interior volume. It'll work great in the cooler climates, but if you're in Las Vegas and it's 120, or you're in Texas and it's 105 with all the humidity, that compressor is going to take a while to cool down the interior of the chassis. You really need some more volume. If you run the GM alternator, it's a good alternator, and there's different setups. There's the Camaro Corvette setup, there's the truck setup, there's Gen 3, there's Gen 4. One advantage of the Gen 3 alternator is it's self-regulating. So it has a regulator built in, and it will charge 14 and a half volts standalone. It does require, at least most of them do require, an exciter wire to get it to work properly, but that's pretty easy to figure out. Almost all Gen 4 alternators are computer controlled. The ECM actually controls the fields of the alternator. However, the charge goal in the production vehicles is not done by the ECM. It's usually done by a generic module or a body module, because that module is better suited to analyze system voltage, just like the TIPM is in a JK. So what happens if you put a Gen 4 alternator in without that module? It'll work. It'll actually charge, but it'll charge in a limp mode. It'll go to about 13.8 volts, sometimes 13.5 volts we've seen. But it will charge and it will work. It's just not ideal. However, it is reliable, and we've run them in the past, and it works. Now, there's another option there. If you have access to programming, you can do a segment swap and get the GM alternator to charge more efficiently using like a GM Performance alternator charging segment. But that goes a little bit beyond the scope of the swap, because most guys aren't going to do that. If we run a JK alternator, and we'll get to that when we get around to the JK accessories, just talk about the power steering pump. There is a lot of variables on the power steering pump. Now, I like to run a stock JK power steering pump. It's designed for the vehicle, and it works great. They're quiet. The lines that the hoses and lines hook up, I like the sealed reservoir. It's just a really good setup. I don't recommend you run a 7 or 8 power steering pump. They had some issues with those. The shafts would snap under high load. So run a 9 or newer. Actually, if you bought a current power steering pump, I don't think you could get an earlier one. I think they've been discontinued. I do highly recommend you get a Mopar power steering pump. We have worked with a lot of the aftermarket pumps, and the quality is just not there. They whine, they have play, they run out of round. So just stick with a Mopar. Now, the Mopar pumps are expensive, but that's okay. Get a remanufactured Mopar pump. They're under $200, and if you have a core, they're usually about $100, and they work great. So go to your dealership or go online and get a remanufactured Mopar power steering pump for a 7 to 11 JK. It works excellent with our swap. Talking about the GM power steering pump, there's a lot of variables. The truck pump that comes on the 5.3, 6.0, and 6.2s is an excellent pump. There's probably not much out there that's better. The truck pumps are iron, they're very strong, they can put a lot of volume out. They're designed to run not only steering, but on some applications, Hydro Boost braking. So it's an excellent pump. It can also get a little bit tight if you're running hydraulics, because depending on the box you're running, whether it's Redneck Ram, PSC, how, you want to make sure that the ports are in the proper location for your hydraulic lines that go down to your Ram. Many years ago, when we started doing the LS swap and Hemi guys were doing Hemi swaps, there weren't a whole lot of options out there, so we would buy a PSC box and lines would run right into the air compressor. We had to work with them, and now most of these companies, whether it's West Texas Off-Road or PSC, offer what they call their V8, LS, or Hemi box, which runs the ports out the bottom, so make sure you identify that. When it comes to the LS3 Corvette pump, I tend to differ with others' opinions. The LS3 is a good pump for a car with 31-inch tires, 32-inch tires. It can give you really good effort, and they're not looking to have divorced from reality low effort steering like a 1968 Chrysler on a new Camaro or Corvette. They're looking to have a certain amount of feedback. These pumps put out a decent amount of volume, and they can be modified to put out more. But honestly, if you're going to go with 37s or 40s with hydraulics, these pumps, in our experience, just can't put out the volume. You might notice above idle, they work fine, but at idle, especially if you're running an engine that idles at 500 RPM off-road, you might notice some stuttering in the steering or a flat or a dead spot. So I don't recommend you run that pump. Now, we do have options to mount both PSC and JK pumps in the LS3 mounting brackets. So that's a really good option if you do go with hydraulics or you are running 40. We do find that the JK pump does great. Actually, we've done a lot of builds with JK pumps in LS3 brackets. And up to 37s, they're excellent. If you go up to a 40, you're starting to push it. You go to hydraulics, you're pushing it. So then you end up having to put a higher volume pump in, an AGR, a PSC, a Howe. I like working with Redneck Ram, the West Texas off-road guys. They have a lot of good stuff at a really reasonable price, and their customer support is excellent. West Texas Off-Road can help you get more volume out of a JK pump by modifying the control valve, and we find that that combination works in most applications. If you're going to be running out in the desert with 37s and no hydraulics, or if you're going to be running 40s and crawling at Moab, then the JK pump is not going to be enough for you. Just step up to a high performance pump, but know that you have that option with us. You do not have to go out and buy some custom, bespoke, expensive power steering pump. The JK or the standard PSC pump will get the job done for you. Let's move over to the JK accessory drive. As mentioned, we run the JK accessory drive on pretty much all the JKs from 7 to 17 now, and we use it because it works, and there's a lot of advantages. One is the configuration. By putting the JK accessories right back where they were, we're essentially eliminating any interferences or conflicts that you have with other accessory drives. So the air compressor is now on the driver's side lower, where there are no interferences. You can bring your axle right up to the bump stops, and there's zero interference. The alternator goes right back where it was, so it plugs right back in. The alternator now has smart charging. The TIPM is what sets the charge goal for the alternator, just like the generic module or body module would in a GM. The TIPM is the gateway module for a JK, so it has more knowledge of all the other systems than pretty much any other module in the network. So it is the one that is most suited to set the charge goal. So once you have a desired goal, then you need to follow it with the actual, and that's what we do with smart charging and our JK accessory drive. By running the JK alternator, the TIPM sets the charge goal, the PCM has the fields in it, or the ECM in the later JKs, and then the actual follows the desired. If you have an issue, you have a problem, the actual and desired separate, then you're going to throw a code and you diagnose it just like you would normally. There are other options for alternators. We've had guys run the blue or high capacity alternators, and in general they work well. I will say there's a lot of amperage going through these alternators. It can exceed 100 amps, and if you're winching or you've got a fully loaded JK with a trailer and you're pulling a lot of amps out of that alternator, I have seen the wires get hot enough to melt and sometimes catch on fire. So upgrade your wiring if you have to. The main power wire going from the output of the alternator to the battery is especially important. It is protected by a fusible link at the battery by Chrysler, but if you're going to go to a heavy-duty alternator, or you're going to be putting a lot of amperage out for a lot of time, beef it up, go down to a 1 gauge, go down to a 2 gauge wire, and use circuit protection at the battery to protect any overloads. Also, it's super critical that you check your grounds. Ground distribution is not well understood, but it's probably the most important circuitry in your JK. Everything has to go back through the grounds. It doesn't matter if it's coming from an O2 sensor running in millivolts and milliamps, or a starter motor pushing 250 to 300 amps. Everything goes back through the ground. If you combine grounds, which a lot of aftermarket harnesses do, you're reducing the efficiency of the amperage transfer through that conduit. If you combine grounds for convenience or to simplify a harness, you're increasing the load on that leg or that extension of ground distribution. So if you had two 16 gauge wires going into one 16 gauge wire, that one 16 gauge wire goes to ground, you are reducing the efficiency of your ground distribution circuit. You want to run ground paths in parallel, not in series. So that means if you take those two ground distribution wires and you run them directly to the block, you're losing nothing. And in fact, that's what the OE manufacturers do. If you look at a GM harness, you'll see several eyelets, ring eyelets with grounds on them. They're not ganged into one eyelet. They actually use individual eyelets and then bolt them to the block. That way you have multiple ground distribution paths coming off the same bolt. And this is critical because modern vehicles have a lot of electronics going on. You have transmissions with solenoids clicking away. You have throttle position sensor with a throttle body that has electric motor inside. And anything that's driven by a motor is pretty much a high amperage circuit. You have O2 sensors that are operating off of millivolts. Way back in the day, O2 sensors were grounded to the chassis, but they were very primitive. They ran open loop at idle. They didn't have heaters in them. So if you had a ground float of a few millivolts, it wasn't the end of the world. In today's world, computers are so fast that these ground distribution paths have to be perfect. And if they're not, there will be a deficiency somewhere. O2 sensors are ultra fast. They can start switching within 10 seconds of vehicle startup using cold start emission systems. So it's very important that these ground paths remain intact and the way the vehicle manufacturer laid them out. We're talking about the charging system, and ground distribution is critical in proper charging. The engine block is grounded right to the battery. When you crank the engine, a lot of energy is going through that cable. When I was doing general auto repair, we saw the cables erode from the inside out, and that made a tough diagnostic because if you can't see it, you really don't know what's going wrong. But it would literally erode the conduit from the inside out. So you want to make sure that your block is grounded properly. On the aluminum engines, it's pretty easy. Just run the battery cables down to a boss on the block and make sure you stay away from the exhaust. I see a lot of guys just run the battery cables off the battery box along the manifolds and down to the starter. Don't do that. We run the battery cables to the front of the head on the passenger side, run it through a clamp, and then back along the oil pan. Use clamps. This will keep it away from heat and getting burned. Make sure that that battery cable is bolted tight to the block using star washers between the block and the ring eyelet, and get it as close to the starter as you can. It's not a good idea to put it on the bell housing. It's not a good idea to put it on the front of the block. It's going to work, but the actual energy from the starter is being pulled at the starter, so get that ground as close to the starter as you can get it. On the LS3s and the aluminum blocked engines, there is a boss directly above the starter. Use it. On the iron engines, there's not a boss there. So I like to use one of the engine mount bolts because that's relatively close to the starter. Just make sure there's no paint or debris, and you use a star washer and tighten it well, and you won't have any issue. The flip side of the alternator circuit, of course, is the power back to the battery. Make sure you route that properly. We route it under the throttle body and over to the battery, just like Chrysler does. Be very careful on an LS engine, whether it's an LT or an LS. They run steam line. Essentially, an LS uses a reverse flow cooling system, so the water goes from the bottom up. When it does that, it can build air pockets at the top of the heads. So GM has incorporated steam ports at the top of the heads, and that purges the steam out as you drive. There is a pipe that goes between the two heads at the front of the engine. That pipe gets very, very hot, and that's also where you're running your alternator charge cable through. So I've seen guys actually tie wrap the alternator charge cable to that steam pipe. Not a good idea. What you want to do is you want to tie that alternator cable as far away from that steam pipe as you can get it. And it's very easy to do. There's plenty of room in there. So don't overlook that. It doesn't require much diligence to do it right versus doing it wrong or doing it over. When we're running our JK accessories, we're using billet brackets that we build in-house. We machine them from solid blocks of aluminum. The process is expensive and labor intensive. However, we've determined this is the best setup for a JK. By using our billet aluminum brackets and stock JK accessories and putting them back where they were, we can reuse the original power steering lines and reservoir. You literally don't even have to pull the power steering pump off your vehicle when you pull the motor out. Just set it aside, tie it up to the core support. When the swap's done, you just swing it back under the engine, bolt it on, and you're ready to go. There is no reason to open the system up.